All right, guys, I'm back with the rest of Objective 1D, the effects of solute imbalance on a cell. And so this is looking exclusively at the effects of osmosis, which is the movement of water. And I think this is where some of you really get confused. When we start talking about the tonicity, we're only talking about how water moves. So osmosis is directly linked to hypotonic, hypertonic, or isotonic. And remember, this is a type of passive transport. So this is when we're looking at the movement of water from high water concentration to a low water concentration. And remember, we want equal concentration, not equal volume. So the amounts, like how high it is in a U-tube or whatever, doesn't matter. So if I had a U-tube, right, with a semi-permeable barrier, and I had this much water on this side, but it was like 4 particles, and twice as much water on this side, but it was 8 particles, this is equal concentration, okay? So, let me show it to you because you can't see it. Okay, right there. So, on one side, I have a certain amount of water and there's 4 particles, right? And on the other side, I have twice as much water and twice as many particles. This is equal concentration. This is what we're trying to get to, okay? This is the type of equilibrium we want. Versus if I had, say for instance, semi-permeable barrier, right? This side, 4 particles, same amount of water on both sides. This side, 8 particles. This is equal volume. This is not what we want. We want equal concentration, not equal volume, okay? So make sure you pay attention to that. Because with osmosis, you're going to be moving things from an area of a high concentration of water to a low concentration of water. Now, we're looking at solutions in this case. And so you have to understand what a solution is. A solution is water, which is serving as your solvent, and what something else that is being dissolved in water. Now this may say sugar, it may say protein, it may say salt. I like to pretend that whatever it is, it's talking about salt because I like to remember that high salt sucks. If I eat something salty, I crave water. So wherever there's more salt, that's where water is going to go. So whenever I'm given whatever a percentage is, if it's not water directly, I pretend that it's salt, okay? So that's just me personally. Now, a hypotonic solution is one that causes a cell to take in more water than it lets out. Remember, water's going both ways across that membrane, okay? But water can move in more at a higher concentration than it goes out of a cell. So more particles of water are going in than going out. A hypotonic solution is one that if the cell is put in that solution, it's going to take in more water than it puts out. And that's going to cause that cell to swell, okay? A hypotonic solution makes a cell swell. Now the effect on the cell depends on the type of cell. Plant cells like this because they have a cell wall to provide that external support. It's going to give what's called turgor pressure because when the water goes in, it's going to go into that central vacuole, which is going to exert an internal pressure against the cell, which pushes against the cell wall, and it's going to make that cell stand up tall. So this is what a plant cell wants. It wants to be in a hypotonic solution. Animal cells, on the other hand, do not have a cell wall, so when water goes into them at a higher rate than it goes out, it can cause the cell to lyse or burst, which will kill the cell. So, hypotonic, good for plants, not good for animals. If I'm looking at a diagram like this one where I have a cell in a beaker, so the cell is 10% salt solution and the beaker has a 5% salt solution. Remember, the higher the salt sucks, right? There's more salt inside of the cell, so the water is going to leave the beaker and go into the cell. Now, if I look at that as far as math, because remember, water moves from high water to low water, not just high to low, but high water to low water. A solution is 100% of something, right? It's 100% of water plus something. So if I'm 10% salt, that means I'm 90% water inside the cell. If I'm 5% salt outside of the cell, that means I'm 95% water. And the water's going to go from high water to low water. So the water's going to go from outside to inside of the cell. High salt sucks. Now, a hypertonic solution is the exact opposite. The water's going to go out of the cell faster than it comes into the cell. So this is a solution that causes the cell to lose more water than it gains, and the cell is going to shrink. No types of cells like this. Not plants, not animals, okay? In a plant cell, if the vacuole is losing water at a faster rate, it begins to shrink. When the vacuole is attached to the cell membrane is attached to the cell wall. So when the vacuole begins to shrink, the cell membrane begins to pull away from the cell wall, and the cell undergoes plasmolysis. Lysis means to break, plasma membrane, so the plasma membrane actually breaks, which kills the cell. In an animal cell, the cell shrinks, undergoes crenation. In both cases, the cell will die, okay? It's the exact opposite of hypotonic. So there's going to be more of the salts outside of the cell than in. So in this case, the water is going to go to where the high salt is. The water is going to leave the cell, and the cell is going to shrink. An isotonic solution is one where there is no net gain of water. Water is going in and out the membrane at the same rate, so there's going to be no change in the size of the cell. But the problem is, in plant cells, they need that extra pressure, because if the vacuole is not receiving water constantly, it is not exerting maximum turgor pressure. So even though the cell isn't dying, it's going to be a drooping cell. It's going to be flaccid, right? This is going to be like when it starts to wilt. So this one is not good for plant cells, but it's great for animal cells, because animal cells don't have a cell wall, so they don't want their cell size to change. And in this case, your percent solution is going to be the same inside and outside of the cell. We can work a couple of problems in class on this, but that's it. Toodles.